So if you want to, recording in progress. I guess I'll continue talking. Laura, is Laura there? Could you please mute your mic? Or maybe I can. Oh, there we go. Here we go. I can mute others. Maybe like that.
Hey, okay. Scott, I'm here muting people for you.
All right. Thank you, man. Easier to focus that way.
Yeah, I got you.
Okay, so I don't think I need that chat. Okay, whatever. Yeah, so the Python engine. If you have, for example, U, V, and W, your wind vectors on the X, Y, and Z axes, you can use Vapor's Python engine to generate a wind speed variable. So if you want to visualize wind speed, but it's not in your data files, that's something you can use to do that. We're also going to go through the plotting tool, which allows you to plot the values of your data through 2 points in space, or plot your data at a single point in your volume through time. And we're also going to talk about data statistics. You can query the values of your data, get min, max, median, mode, and I think there's a few others. And you know, some people wonder why you would want to do that. And one of the reasons would be because you may have converted your data into Vapor's VDC data format. The VDC data format allows you to look at your data compressed or uncompressed. And the reason you might want to look at it in a compressed format is because with 3D visualization, when you're querying massive amounts of data, the application can become very slow to respond. So as an exploration tool, Vapor has the benefit of offering the VDC format, which allows you to crank down the resolution of your data, kind of get a feel for where your observables are, apply your color palette, your opacity, and then once you think you have what you want to see, then you can crank the fidelity back to its uncompressed level and then press play and do your visualization. And it just allows you to explore the data in a more responsive way before you crank it back up to 11 and do your full visualization. So I guess going back to my point earlier, data statistics and plotting your data allows users to kind of see what the VDC is doing to their data. Like, is it really messing with things? And you can confirm it with the statistics tool or the plotting tool. And for some people, I don't know. I think everyone wants to look at their actual true data for their final visualization, but there is always the question, what is the VDC, the compression that the VDC is doing? What is that doing to my data, and how's it affecting my results? So yeah, at the very end, we'll talk about how to get your data into VDC if it is massive data and the application is kind of unresponsive. And then lastly, we will talk about the CF conventions, which is kind of a set of guardrails that Vapor uses to, to basically read the data, read generic, in quotes, generic net CDF data. So as long as your net CDF data follows the CF conventions, Vapor will be able to read it. But if you're a WRF or MPAS user, we support those formats natively. But we still get a lot of questions about the CF conventions. So I'll touch on that at the very end. Okay, that's my intro spiel. I guess the first thing I'm going to do right now is exit out of my presentation, and hopefully everyone's installed Vapor at this point. But if not, you can just follow along with me. I'm on my Mac right now, so let me do a little bit of cleanup here. Get out of here. Okay. Yeah, whatever. All right, there's my desktop back there, everyone can see. So once you've installed Vapor, at least on Mac, you'll have this V at the very bottom, and that V is for Vapor. I'll click on that, and then here's the basic application. The first thing that I'm going to do, and the first thing that everyone will need to do after opening the application, is to get your data into Vapor. And so I'm going to click on the File menu, down to Import. You can see there's an option to open a VDC if you convert the data, and we'll talk about that more later. But I'm just going to directly import my data by clicking on WRF ARW. And I get this dialog where I get to browse for my data, and I'll just go to my Katrina directory, for simplicity, I'm just going to pick 3 of my Hurricane Katrina files and click on open. So the first thing we see here in our visualizer window is this, this box right here. This is our data domain. All the data that we've imported exists within this box. To control this window over here, you use the left mouse button to rotate the scene. The right mouse button will zoom in and out. And then the middle mouse button will traverse like this. And so those are the tools that you use to kind of navigate and move around within the domain of the data that you've loaded. The next thing I'll do is click on this new button over here. And that's going to open a dialog that, again, displays all the renderers that are available to us. And the first one I'm going to start with is the image renderer over here, which will give us a context for where we are in space. It doesn't really, it's not really obvious to us where we are, what we're looking at, where we are in the world until we get a map at the bottom. And so I'm going to click on image, click OK. And then we can see over here that I have an image renderer populated into my renderer table. The name is the image renderer. The data set is the file that I've loaded. And then basically to turn it on, I'll just click on this checkbox. We can see for Hurricane Katrina, we can see Louisiana right here. But it's not completely obvious that this is Louisiana, at least to someone who's looking at this for the first time. So what I'm going to do is go to my geometry tab. And like I was saying earlier, this tab controls where you're rendering in space. And the image renderer is unique in that it lets you extend the rendering outside of the data domain, because this image is just a map. It's not really data dependent. And so what I can do is I can right click on these handlebars and drag them out like this. Zoom out a little bit more. Right click on that one, bring it out. And there's Florida, and there's the Gulf of Mexico and the Yucatan Peninsula. And now we have a better idea of where we are in space. So again, that's just right clicking on these handlebars, dragging them out until we feel comfortable that the image renderer is big enough for our domain. I'll go over to the variables tab, and one of the things that the image renderer allows us to do is apply a height offset. And so this isn't the greatest example because we're looking at Louisiana. It's very flat. But if our data set has a height variable, I can click on this list, and this will list all the 2-dimensional variables in my data set. I can go down and select HGT, and that's completely imperceptible what that did. But if we look, if I zoom in over here, maybe I can get some of the Appalachian Mountains. Let's see. You can kind of see how this bumped up. It bumps up a little bit right there. And so in a more mountainous terrain data set, this would have a different effect on the appearance. So if I go back to none, this is going to pop it back down. And then if I go back to HGT, pops it back up. And so, yeah, this isn't the greatest example of that feature, but it's useful to a lot of people, but maybe not, in every data set. So that's the variables tab for the image renderer. I can go over to the appearance tab, and the image renderer has the simplest appearance tab because there's really not a lot of options compared to the other renderers. There's no color and opacity that needs to be specified. So yeah, I guess I can go through the options real quick. Geo referencing, if we turn this off, then we get the entire world within the geometry we specified. So 99.9% of the time, if you're using the image renderer, click on the Geo Reference tab or checkbox, which is the default, and then the image will be aligned with the domain of your data set. Ignoring transparency, if we check on that, is that a bug? Or maybe my map is not. Maybe there is no ocean in this one. So, is there a question? Oh, I don't know. I'll just move on. So I'm going to go down and pick a different image file. Vapor comes with a series of different geo-referenced images. Big Blue Marble is my favorite. Let me see. Go back up. And here it is, bigbluemarble.tms. This is a tiled map image. So it's kind of like Google Earth. These images will change in their fidelity depending on how big they are. So I'll click on bigbluemarble.tms, and there we go. We have our land masses and our oceans, and back to what ignoring transparency kind of provides as a feature. Click on that and the oceans are now transparent. And for ocean modelers, you want to see through the surface of the ocean. But if you're doing atmospheric modeling, you can turn that on and kind of get the bathymetry image of the ocean. Opacity can be turned down and up. Usually I crank that all the way up to 1. And then the TMS level of detail, usually default is sufficient, but if you zoom way in and you think it's kind of grainy, it doesn't look good enough, you can crank that all the way up and it gets a little bit better right there. We don't provide super high res images because that's going to cause vapor just to be too massive to distribute. But on our website, we do have a 500 meter TMS image that you can download. So if you go to our documentation website, you can find a link to that there. So that's basically the image renderer. I can go to the geometry tab, but we've already been there. And yeah, I think that's good enough for that right now. So I'm going to move on to the next renderer, which is the slice renderer. So I'll click on new, click on slice, and click on OK. And we can see our new instances up here. And if I click on my image renderer, I just want to emphasize that now we're looking at our image parameters in the control panel. But if I want to modify my slice parameters, I click on slice, that's now highlighted, and we have our 4 tabs that pertain to our slice renderer. So again, the slice is just a, it's just a cross-section of 3D data through our scene. So right now, by default, we're looking at our pressure variable. Maybe pick something more interesting than pressure, maybe do Q rain, and then just turn it on. And then by default, we have a slice on the XY plane right in the middle of our domain. So this is where things get a little bit more interesting. If I go to my appearance tab now, here we have our transfer function, which is just a distribution of the values of our data. And if we look at Q rain, we see we have a ton of values over here near 0, and it kind of tapers off. If I click on this slider over here, I can zoom in like that. And man, there are just not a lot of values above 0. But basically this slider controls the minimum and maximum extents of the transfer function. In this case, there's one thing I can do. So we have a few values, spackled over here that are non-zero. I'm going to right click on the transfer function, or actually no, it's this gear icon. And the scaling, let's see, histogram scaling, I can look at linear, logarithmic, or Boolean values on the y-axis. So if I click on logarithmic, now we can kind of see the y-axis is now logarithmically scaled, and we get a better idea of the distribution of the values, aside from 0. So that's the distribution, but how is color and opacity being applied to these values? So we see this logarithmic distribution, logarithmic on the y-axis, and color is being applied to these values based on this color bar that we see down here. So values that are 0 are deep blue, and we go through this color interpolation to white at the middle and then red at the end. That's how color is being applied. This is called a divergent color map because there are 2 colors that diverge from a midpoint. And divergent color maps are best suited for modal or bimodal distributions, but this is more linear distribution. And so I'm going to click on the gear icon again. I'm going to load a built-in color map, and I'm going to pick a sequential one. So let's see. I don't know. I think this one. I think black body is typically my favorite. And so now we have a different color map, a non-diverging one for a more sequential data distribution. So let's do this. I'm going to bring this out here. And now I'm going to start applying opacity to the slice renderer. Let's see, get something more like that. So we see a lot of black in there, but if I click on this color point or this opacity control point, this bar, the lower I bring it down, the more transparent those values are going to be. So I've just masked out all of my 0 values, and I'm ramping up my opacity along this line until we get to this data point. We can see this data value is 0.00128. So at 0.00128, or now 00130, we are at full opacity. All those values are going to be completely displayed. But if I drag this down, now I'm masking out those values and then ramping it back up like that. Yeah, so let's see, that's kind of the basics of the transfer function. We're going to be touching on this with more renderers moving forward. I mean, I can go through the geometry tab again. Let's see. So yeah, I guess the slice, I should do this. So the orientation is something that's kind of important with the slice renderer. Right now, we're looking at the XY plane, but we can change that to XZ. That's a little hard to see right there, I know, because our domain is so small on the Z axis, but I can zoom in more. And let's see if I can show more values by dragging this over. So there I'm dragging and something like that. So back to the geometry tab, I can change the orientation to YZ as well. And then all these are by default smack dab in the middle of the domain. We can change the location of the slice like so by sampling along the x-axis, moving back and forth. And then like the other renderers, there's the region selection where you can constrain the area that you're drawing to. So you can see we kind of chopped it right at that point. Okay, so that's the slice renderer. At this point, what I'm going to do, I'm going to zoom out. I'm going to save my session. So every application in the world is kind of obligated to have a save state in it because you don't want to lose your work. So right now, I'm going to click on File. I'm going to save my session as WRF 2021 in my home directory. Save it, and let's say my computer runs out of batteries or Vapor crashes or some situation happens where I lose my work. I just closed Vapor, it's gone, and that happened after I saved my session. So what I'm going to do is open Vapor back up by clicking on the V, go to File, Open Session, and then I can open that, and I should be at the same place where I left off. So, and FYI, Vapor automatically saves your session after, I think by default, every 5 changes. And so if I move my scene 5 times, Vapor will save a session file in my home directory called Vapor Autosave. So if let me open up a terminal and zoom in so everyone can see it. So if I do ls lrth on my home directory, Vapor Autosave just happened like 20 seconds ago. So if you forget to save your session, just keep in mind, Vapor Autosave.vs3 will be in your home directory every 5 changes to the scene. But if you have a point in your work where you want to explicitly save a perspective, then save your session manually, like I just did with WRF 2021.vs3. All right, so at this point, I think I'd like to give a 4-minute break and just for people to play around with these renderers if they've caught up or ask any questions. And if this is useless, like I said earlier, I can just continue showing renderers, but I don't know. I think there might be a use for people to play around with the application like there is in our live tutorials. So I don't know, maybe things are different because this is virtual, but here we go. I'm gonna put 4 minutes on the clock. I'm gonna check out the chat and take questions and see if, I don't know, see if this is useful. Please resend videos and tutorials. Yeah, let's see. Actually, so let me respond to Fernando. Wei Wong of the WRF software team sent that email I'm going to ask her to resend it because I actually don't have your email addresses. So let me send her a note.
What do they need?
Fernando's asking for, there was an email that was sent, I think on Friday, that contains some tutorial videos and sample data to download.
Yeah, unless they joined in just today, they should have received the email. Yeah, like I said, this email, I've sent the latest one actually in the morning for the latest registrant. But if you just reply to one of the messages you sent, that will come back to me, and I can resend you the email. Most of you should have received it. Yeah.
So this must.
Whoever did not receive this email, send an email to the, for instance, the workshop general email, whatever you have received to be able to join this meeting. And send an email. I'll pass on the Scott's email to you. Yeah.
Okay, sounds good. If that doesn't work out, I can probably figure something else out too.
Yeah.
So cool, I'll just keep moving down. Looks like we have some other questions. How do I create an animation if I'm opening multiple WRF files? Yeah, so that was something I was going to touch on, but I can just do it right now. So if you noticed at the very start when I imported my 3 WRF files, that was multiple time steps like what you're talking about. So to animate, what we see up here at the very top, we're looking at time step 0 relative to the files that I've imported. So there's 0, 1, and 2. To move forward 1 step in time, I can click on this play button. And then again, and then you can see my domain kind of moves. This is a moving domain with Hurricane Katrina. So you don't have to do this manually, click by click. You can use these play backward and play forward buttons. And so if I do play backwards, I guess I'm looking south right now. It might be easier if I look north along the trajectory of the hurricane. So I'll play forwards, and you can see the domain kind of inches forward a couple of steps. And so to answer your question, it's just these VCR controls that are up here. Okay, can you teach me how to enlarge the background map, the whole map? When I moved, the whole map moved out of the box. Yeah, so to enlarge the background map, I'll click on my image renderer row, and that's going to populate my control panel with all the controls for the image renderer. I'll click on, not the appearance, but the geometry tab. And then to enlarge it, I have my red handlebars. I will right click to enable that handlebar and drag it out, and then release the right mouse button on each of the axes. And that will enlarge or reduce the image. Let's see, how far do we go? Yeah, so I think that answers that, but I'm not sure what you mean when I moved the whole map moved out of the box. If that didn't make sense, maybe we can do a follow-up with Sam or Stosh or myself later. How do I upload information into Vapor? Download Katrina files and import via WRF. So that should be, let me scroll up in the chat. So in the chat window, I sent some links to two compressed archives that contain the data that I'm looking at right now. Whoops. Well, there's the link to Katrina. Didn't mean to click on that, but if you do click on this, you're going to come to this web page and you can download it there. I'm not sure if I'm not sure if everyone can see my chat window. Let me ask real quick. Can you guys see my chat window as I'm going through these questions? Can I get a yes or no from anyone? No, you cannot. Okay.
I can.
Huh. So, okay, guys, I guess I have to explain this with words because I'm not sure how to show you exactly what I'm looking at. If you scroll up in the chat window, I think, okay, if you get past all the yeses in the chat window, I sent some links to the data files. I might as well just copy them and paste them again. Okay, so I just put in a link to the Katrina files in case anyone missed that the first time. And then here is a link to the tornado files that we'll touch on later.
Hey, Scott, I'm not seeing in the chat. Is it select to send it to everyone, or are you sending a private message right now?
Oh man, you're right. I'm sending it to Fernando. So sorry about that. Let's see. Okay, so dude, there's the CM1 tornado again.
Sweet, perfect.
This is the Katrina. Chat's getting crazy. Maybe we need a couple more minutes. Let me tear through some more of these questions. Is it possible to add shape files to our plot in Vapor? Not yet, dude. Okay, check out the survey. I'm going to send another link out at the end to our survey, but this is this is the kind of stuff that we need to get more demand for in order to implement this. So if you guys fill out the survey, I might as well just send another link to it in the chat right now. But if you want to see shape files in Vapor, or you have any other requirements, fill this out. And this is exactly the kind of thing that we're looking to do next. Can I save a plot in JPEG or PNG? A plot. So yeah, I think Stosh is answering that question. If you're referring to a rendering, if this is what you're referring to as a plot, if you alternatively go to our plot utility, which I was going to touch on this later, you can create graphs and stuff. So I can create a plot like that, and I'm going to touch on this later. You can create a graph between 2 points that plots your data. But I think you're probably referring to the actual visualization. So I think Stosh answered that question there. Okay, moving on. My image, the black background is only at 25% of the viewing area. I hope I answered this question with the image. If you go to the geometry tab again on the image, so make sure you're selecting the image row, you go to the geometry tab, and then you will see these red handlebars that you can manipulate with a right mouse button click. So if that doesn't make sense, ask again and we can talk about it some more. Is it possible to export a PNG of the actual visualization? Yes. So that is done in the capture menu up here. Click on capture. You can capture a single image. So if I do that, I click on PNG, Vapor will ask for citation, and then I will call this test.png, save it. And then this will be in my home directory. I sort by date modified, test.png. I'll open that up and there's the image. The other way to do it though is if you're capturing a time series and you want to make a video, you're going to click capture image sequence and then click PNG and then give it a prefix. I'll call my prefix. And then what's going to happen then is Vapor will then capture every change that happens, whether it's through a time series or whether it's your mouse moving the scene. So if I click on the backwards play button, Vapor has captured 1, 2, now 3 images. If I go to my Explorer, I can now see 3 images that have been captured through time, through my time series. But if I start moving the scene around like this, Vapor is now capturing a PNG for every time I touch the scene. And so I'm going to turn that off right now by clicking capture, end image capture. And if I go to my Explorer, you can see 1, 2, 3, 4, 5, every time I move the scene, Vapor is capturing an image. So yeah, I hope that answers that question. How do I compare 2 files of the same spatial extent? That is, so to do that, you would import to compare 2 files of the same spatial extent. So if you wanted to do that, you would go to File, Import, and then let's say we're comparing WRF ARW. And then I'm going to pick a different WRF file than the one I imported the first time. This is going to load this WRF file as a new data set, as we see right here. I'll click OK. And then I can click on the New button. And then I can create a new renderer. Let's see, I'll click on Slice, make a new slice. And then up here at the top, where it says Data Source, now I have 2 data sets that are loaded. The first one is the first data set that I loaded, and this one down here is the second one. So I can click on the second data set, click on Slice. Now I have another slice that I can enable as a secondary data set. So now I'm comparing 2 different time steps of my WRF data. right now. I'm not comparing them very well, but I hope that's good for demonstration purposes. So I'll go ahead and delete that. Yeah, Stosh, yeah, how do I add a color bar? Stosh got you there. Go to the slice renderer, click on annotation, and then show color bar. Click on that, and there's your color bar right down there. Does it provide the same capability with the other NC files, the observation and the reanalysis? This is one of our questions in the survey, observational data. We don't support observational data yet, but I think it's coming. So gosh, the questions are rolling in. I think it's been about 10 minutes. So I'm gonna keep on cranking through the renderers, guys. I think Stosh is doing a good job keeping up with the questions. And Stosh, I think, actually Stosh, I think you're direct messaging me for some reason. That got me earlier. Yeah, so Stosh, there's a few questions. The color bar response was sent to me for whatever reason. And then Fernando, you're directly messaging me. So who knows what Zoom is thinking here, but it got me too. So guys, make sure, yeah, it auto switched. I don't know why. But make sure, guys, when you ask questions, ask them to the whole audience. Otherwise, I probably won't see them because my eyes are on the screen, not the chat window so much. But okay, we've gotten through 2 renderers. Let's keep cranking through. I'm going to go ahead and turn off the slice just to get things out of the way. And I will click on new. And the next renderer I'm going to touch on is the 2D data renderer. So not all of your data in your WRF simulation is 3D. You have 2D variables too. So I'll double click on 2D data. And there's my renderer. Go to my variables tab, and I'm looking at CanWatt. I don't know what that is. But I don't know, maybe or V10. Let's look at V10, X wind component 10 meters off the ground. Turn it on. And you can see we don't see it because it is at the same Z position as our image renderer. And so I'm going to turn off the image renderer. And then there is V10 right there. And it works in a lot the same way as the slice renderer. So I can go to my appearance tab. And here we have a, I don't know, trimodal distribution, whatever you want to call it. And the same principles apply as the transfer function in the slice renderer. You can drag this down, apply opacity, and modify the extents of the transfer function with these sliders. Or I can grab these color control points and modify my color bar down there. And you know, all these renderers, the goal when we designed Vapor was to make all the renderers behave in the same way. And so it's really the same thing as for the slice renderer. We're just looking at a 2D variable down on the ground. And if I go back to my variables tab, we can see not only can we pick our primary variable name, we can also apply a height variable to the 2D data renderer in the same way that we did with the image. So I don't know, we are looking in Louisiana, so height's not very interesting. Let's try temperature. What's that going to do? Temperature doesn't go very high because Vapor is reading the height in terms of meters. So I don't know if I can give a great example. Katrina's not the best data set for demonstrating the height variable, but let's try something that's going to be maybe, I don't know. Yeah, well, I don't know. If we had a better example data set, that would make more sense. But that's the 2D renderer. Same thing as the slice, but just in 2 dimensions. Another 2-dimensional renderer we have is called the contour renderer. So I'm going to turn this off, click on new, and then double click a contour renderer. And as you might guess, this is just a contour plot along a 2D variable in our data set. So turn that on just like everything else. We're looking at CanWatt once again. And let's see, what's a better variable? T2. So there is a set of contours of our temperature variable. I can go to the appearance tab now, and there's these new control points that we have down here. These are specifying where the contours are being drawn in our data. And so I can click on these and adjust them, drag them back and forth. I can delete them, I believe. Let's see. Contour count. Okay, yeah, to delete them, I modify the count. So if I want 5, I can just draw 5 if I want. Let's see, can I go to 50? I can. Or maybe, okay, so we have 50 right now, but the contours are exceeding the extents of the data. So we can see that with this red control point over here. So let's see if I drag these in, there we have our 50 contours and we get this, I don't know, neat contour plot. Modify the minimum value with that control bar there. And then you can see there is a color palette being applied to our contours. If we want to turn that off, we can use a constant color. And then we have a color selection box that pops up where we can pick RGB values if we don't want to use the color bar. So those are the 2D renderers, the aptly named 2D data renderer and the contour renderer below it. So yeah, that was kind of one of the sections. I'm going to go back to the questions real quick before we go on to some of the more exotic 3D renderers. So let's see. Can't hear well. Let's see, I don't know, is anyone else having audio problems? Okay, cool. Yeah, it might be on your end, James. So I'm not sure what to say there. Will this chat be shared as well? I don't know, maybe I can copy and paste it. How do you do this? File? Dropbox? Google Drive? I don't know.
Hey, Scott, I'll get a copy of the chat because I'm recording this as well. So I think it actually will record the chat as well. But
okay.
I'll make a dump before we go back to the main room as well.
Great, awesome. That makes it easy.
Yep.
Okay, and it looks like my chat went back to Fernando for whatever reason. So I'll switch my chat back to everyone. And yeah, Stosh is hitting all the questions. Sam is hitting the questions. Can we zoom to a region in our data set and visualize it in Vapor? Yeah, so to zoom in and out, that's your right mouse button. And so if I was to zoom into the eye of the hurricane, I would click my right mouse button, hold it down, and then push it away from me, and that'll zoom in. And then to zoom out, I'll pull my mouse back out. Okay, so let's move on to some of the other renderers, probably some of the cooler ones. What I'll do first is I'll scroll up in my table, disable my contour renderer, and let's clean up my table because I'm not going to really use these anymore. So I'm going to delete my contour renderer. I'm going to keep my image renderer, turn it back on because it's not going to be in the way anymore. It's going to be, yes, like the 2D data renderer, it's in the way, you know, it's coplanar with the image. So I'm going to delete the 2D data renderer, keep the image, and I don't think I need my slice anymore. Delete that. All right. The first 3D renderer, I'm just going to get it out of the way. It's simple, not so useful, except if you're trying to debug something, but it's called the Wireframe Renderer. I'll click on that, click OK, turn it on, and there it is. In our wireframe, this, believe it or not, this is the mesh of our data. You can kind of see it here at the edge, but the mesh is so dense for the screen I'm using that, you know, it just appears as a big red brick. But one of the things that you can kind of see with the wireframe renderer is the layered grid of our WRF simulation, the high density of cells towards the surface, and then as we go up in the data set, the layers get further and further away from each other. And just like the other renderers, there's an appearance tab. You can modify the colors that are applied, but really this is more of a debug tool than anything. I'm not sure I've seen the wireframe renderer actually used in a scientific publication. So, you know, just for completeness, variable selection, you can do this on 2D or 3D variables. I pick 2D. There's CanWatt at the bottom, but it's fighting our image renderer. So if I turn it off, there it is. And then back to the wireframe, there's our variable name, you know, same thing as what we've been seeing so far. So let's move on to something more cool than that. Let's do the volume rendering. I'll click on new, click on volume, click OK. And this is like one of the coolest renderers, I think, in Vapor. Probably volume and flow are I don't know, probably the most beautiful in my opinion. So like the other renderers, I click on this enable box, and immediately we see kind of this big red brick. And when we start using these 3D renderers, we can kind of get a sense for why 3D visualization is so challenging. There's so much data that we're looking at right here compared to a 2D visualization where you're just applying color to a slice. So we have to filter some of the data values. Otherwise, we're not going to be able to see, anything inside. Right now, we're just looking at the top values of our 3D data set. So we can pick on a more interesting variable than pressure. Let's do Q cloud. And here we are looking at the very top of Hurricane Katrina. Let's enable our image just for context. And then I will go to my appearance tab. Whoops, I'm looking at my image renderer. That's what's highlighted there. So I'll click on volume. And now we're looking at appearance once again. Here's our transfer function. And like I did earlier, to filter data values, I'm just going to filter out these 0 values. And so now we can see into the data set. And again, we default to this diverging blue, white, red color map. So I'm going to pick a sequential color map because this is not a modal distribution. Load built-in color map, sequential, and let's see. I don't know. I always go to black body because I think it's great, but let's see, this one, thermal, is kind of cool too. So let's see, what am I going to do next? Probably, I'm going to bring this over. Yeah, see, we're seeing too much of these dark colors. We're not really seeing into the volume. So if I drag this over, I don't know, that seems like we're masking out too much. But it all just depends on what you're trying to see. Like if you're trying to get into the eye of the hurricane, you do want to mask out most of your values. We can also look at a cross section of it by clicking on the geometry tab, scrolling out, right clicking on my red handlebar, and then dragging this down. Got a message from Sam. Hold on one second. So Sam's suggesting that I spend more time explaining what a volume rendering is than explaining the controls. And I guess the way I would explain it is that it's, gosh, I don't know if we want to go into like technical terms like ray casting, but it's basically each pixel on my screen is doing what's called ray casting, where it's basically shooting a laser beam through each pixel on my computer screen and then sampling the data as it traverses the values of the variable in the volume. The rendering is sampling the data and then applying color and opacity to it according to the transfer function, which is working the same way as it did for the 2D renderer, the slice renderer. It's just applying color to the histogram according to these colors on the bar, and then opacity according to this these line segments, which I can manipulate by clicking, dragging them. I can double click them to delete them. I can also click on the line itself and apply opacity to all the values under that line until I mask the whole thing out like that, or drag it up and apply complete opacity to the values under this line. If I scroll down, gosh, there's some more tools down here. These are kind of more advanced tools for users. There's lighting utilities, so you can change the ambient lighting with this slider, and it's pretty self-explanatory. Diffuse lighting, if you know about lighting and graphics. But I don't know, I think the default values are suitable for most users. Ray tracing algorithms, again, this is pretty advanced stuff. You probably won't touch this unless you're dealing with large data and you're trying to get a certain aesthetic. Yeah, I'm not sure if that helped explain what a volume renderer was, but I don't know, Sam, if you had more to say, maybe you could put it in the chat. I'm not sure. Let's see. One question here. Well, gosh, do I go to questions now? Let me cover the ISO surface renderer real quick, and then we'll have another Q&A session. So that's the basics of the volume renderer. I'm not sure if I missed a point I should have talked about, but if there are questions, hit up the chat box and we can address them that way. I'm going to move on to the isosurface renderer by clicking on New, Isosurface. Okay. And then I'm going to turn off my volume because, again, the isosurface renderer is basically a contour in 3 dimensions. And so P is probably a good demonstration of how the isosurface works. I'll turn it on. And here is an isosurface of our pressure variable in the middle of the hurricane. If I go to my appearance tab, we have this little marker kind of similar to what we saw in the contour renderer. I can drag it along to change the ISO value that is being used to draw our isosurface. And so if we want to have an isosurface of, well, minus 600 millibar, we can type it in like that. And every point along this surface is at 600 millibars. And again, this is the distribution of our value. In this histogram, we can click on the control points and apply opacity. And we can create new isosurfaces, I believe, by double clicking on the histogram. So right now we have 2 isosurfaces. You can't see the second one because it's contained within the first one. So if I, let's see, if I apply opacity with these control points, let's see, I'm gonna make this one kind of opaque, and I'm gonna make the other one. So let's see if this is gonna make sense. And then I'll drag this up. Okay, so what I've done here is I've created 2 isosurfaces with these control points, one on the left, one on the right. And the one on the left at roughly negative 1700 millibar, it has full opacity. So this blob right here in the middle, it's fully opaque. And I've applied transparency somewhat to the outermost isosurface, this transparent one on the outside, by I don't know, creating this line and then dragging it, you know, up or down to apply transparency. So I hope that makes sense. I guess the point I'm trying to make here is that you can create multiple isosurfaces and apply transparency to them at different levels so they don't occlude each other necessarily. Another thing I want to talk about with isosurfaces is color mapping them. So if I go to my variables tab, some of the renderers have this option to make a color map, apply a color map variable. And by default, we're mapping our renderers to the variable that's being rendered. But what you can do is make a rendering of a variable and then apply a different color to it. So that's probably going to make more sense if I actually demonstrate it. So for my color map variable, I'll just use temperature, go back to my appearance tab. If I scroll down, let's see, where is, okay, I have to click on this checkbox to color by another variable. And then I have a secondary transfer function down here. I'm gonna go ahead and, I've got too much going on here. I'm gonna delete this isosurface by double clicking it. So now we're looking at just this one at negative 1700. And so every point on this surface again is at negative 1700. And then the color map down here is being applied according to temperature. So we can see also you can select your color map variable in the appearance tab by clicking on T. And I can edit this color map transfer function so that I have a surface of pressure and then a mapping of that surface to temperature. Again, there's lighting parameters similar to what the volume renderer is providing that we went through a little bit ago. If I scroll back up, yeah, that's basically the gist of it. The isosurface appearance tab is probably one of the more complex ones, but it kind of works in the same kind of way as the other renderers. I can go to the geometry tab and edit the region that we're drawing to. So if I right click on that handlebar, I can kind of cut my surface in half and look into it from the other side. Let's see. Yeah, so kind of the same thing as what we did with the slice and the volume. And then just to reiterate the annotation tab, we can put in a color bar in the annotation tab, and there that is in the bottom left of our visualization. So those are the three, I don't know, those are three of our biggest or most important 3D renderers. I'm going to open the floor up to questions now. Let's see. I'll take 5 minutes for this. Can we export images for publication with legend and axes? Yeah, let's go ahead and do that right now. So we have our ISO surface rendering here. The color bar legend is done on a per renderer basis. So each renderer will allow you to create a new annotation. So if I go to my volume renderer that I had earlier, I can create another color bar for it. And it's superimposed. By default, it's in the lower left corner. But if I wanted a volume renderer annotation, I guess it has to be enabled as well. There it is. So for each renderer you create, you have the option to create a color bar for it and then position it in different locations like so. But if you're thinking about another kind of annotation, I guess like an axis annotation, that can be done on the scene tab. And then here we have some tabs we're trying to clean up a little bit in our next release. But if you click on scene and then click on the annotation tab, the first thing that you'll see is the option to create tick marks. And they're a little bit occluded by my image renderer. So I'm going to turn that off. And that's one way to, I guess the only way to get axis annotations into Vapor. And if you want to annotate, these are in meters, these annotations, but you can do that in latitude, longitude by clicking on annotate with lat long values. You can modify the text color, the background color, and all these different features. If you scroll down, there's some other kinds of annotation like time. I can annotate with a time step number. And right now that's a little bit occluded by my color bar. But let's see, I can move that around with these sliders. Turn on orientation arrows. Let's see, what these allow us to do is kind of like point us in, all right, give us a feeling of where we are looking at in space. So we have a red, a green, and a blue arrow that correspond to the X, Y, and Z axis. So X, Y, Z points to RGB. So looking up on Z is along the blue, and then positive on X is shown in the red, and positive on Y is in the green. And let's see. Those are the basics of the other annotations that we provide. Again, color bar is on a per renderer basis, but there's a lot of kind of global annotations that we provide in the scene annotation tab. So let's see, I'm gonna clean this up a little bit. And then turn off my time step. Let's see. What are some applications for Vapor? Is it only used for research at the moment? I believe so. I think this is a predominantly scientific application. I'm not aware. I am familiar with some aerospace companies who've used Vapor, but I think it's also for research purposes for them too. I'm not aware if it's been used for educational purposes yet, but maybe it has. So yeah, I can't say I'm too sure about that one. Is it possible to use a 3D image map too? The only kind of sense that we support 3D images is by applying a height variable. So if I go to my image renderer, it's the only way to get this to be 3D is by, like I said, applying a height variable. So HDT, and again, this is a terrible data set to demonstrate height because it's just so flat over here. Let's see, I can go to my geometry tab. And one of the things that we can do is we can scale our renderers. So if we have two data sets and we're trying to align them, or we're trying to increase the scale of the Z-axis, we can use this table down here. So if I scale my image by 10, okay, that looks a little bit better. You can kind of see the Appalachian Mountains. Let's see if I can zoom in on this. But then you can see where the height data kind of clips off. It doesn't get applied to the map because we only have height data for the domain of the data that we're dealing with. So that's kind of the only way that height comes into play. Is it possible to stretch the vertical axis? Yes, it is. You can do that on a per renderer basis. Right now in Vapor 3.4, there is a bug that will be fixed later this month. But to scale the entire domain, you would go to the scene and then the viewpoint tab, and then you'd be able to scale the Z-axis like this. But again, there's a bug we're trying to fix that prevents that right now. But you can do it on a per renderer basis. is it possible to convert GRIB or regular NetCDF files to VDC format? So a GRIB reader is like one of the requirements we have in our survey. We're trying to figure out how many people would make use of that. So fill out our survey and put a big yes on that one if you want to see GRIB support in Vapor. Regular NetCDF has to be CF compliant. And so, gosh, I'm going to try to talk about that. I think I have 20 minutes left. I want to tear through some important points. And this is one of them, getting data into the VDC format, talking about Python. I'm going to put the questions down for a minute and see if I can demonstrate a couple more renderers. So I'll turn off my ISO surface, my volume, and I'll just go ahead and, whoops, I deleted it. I will Command Z to, let's see, edit, undo. Whoops. There we go. Okay. So I deleted my image renderer just now, and I undid the delete to bring it back. Delete the ISO surface. And I'm going to go through the barb renderer real quick because I know that's an important one to a lot of meteorologists. So click on the new menu, double click on barbs. And then, like always, enable it like that. And there we have a set of arrows that are defaulting to our UV and W field over here in the variables tab. We are looking at 3D variables, but we can optionally look at 2D variables where we default to U10 and V10. But going back to 3D, yeah, so UV and W, color map variable is T, but we're not color mapping right now. We can if I go to my appearance tab and uncheck use constant color. So I uncheck that, and now we have this transfer function applying color to our barbs. So I can modify these control points and I don't know, change their color. I don't know, I probably, if I had more time, I would tweak this a little bit more. There are these parameters down here for specifying how many barbs you want to look at. So you can, if you want to look at, what's the maximum? Maximum is 50. Okay, I'll go 50 by 50. And then if you want even more, you can right click on the slider or the text edit right here. And you say, I don't want 50, I want 100. You can type that in there. And then you will be able to slide that value up to 100, but it's getting pretty busy in there. So I guess that's just an example. So yeah, I'm modifying the number of barbs on X and Y, but I can also add barbs to the Z axis. You probably only want one barb on any given axis at a time. Like for example, if I put this up to 5, it's going to get too busy. You can't really see what's going on in there. And so it's good to have a set of planar barbs in general. I wanted to do barbs that are kind of horizontally open oriented. I can do that by specifying, just the number of barbs I want on each axis. And then I can modify the length of them like that. And then also their thickness. Okay, and then geometry tab, same as always. You can control where you're going to draw the barbs to by right-clicking these handlebars, and that will, constrain the region you're looking at. I was going to talk about the model renderer, but I don't think we have enough time for it. The last thing I really want to do is talk about the flow renderer. And the flow renderer, I think, is best demonstrated in that second data set that I sent out, the CM1 tornado data set. So what I'm going to do is I'm just going to create a new session. I'm going to kind of abandon all the things I've done here and just do something new. So here's Vapor in its blank state. You can see through the visualization window and there's nothing there. So I'm going to click on import, and instead of WRF ARW, this data is NetCDF CF compliant data. And I'm going to talk hopefully more about that in a minute. Click on CF, and then I'm going to go to my directory called May control. And I believe, yeah, I have these files that are kind of trimmed. This is a pretty big data set. So I'm going to click on the trimmed version, which is the one that I distributed to you guys through the email. So just to get a sense of what this thing is, I'm going to make a quick volume renderer, turn it on, and here we can see the tornado right here on the side. Let's see. This is the top of the vortex, and here's the bottom of it over here. I'm going to go to the appearance tab and just mask out some of the values. Let's see. Let's just keep the high values. And what variable is this? Vorticity? No, this is just U. Okay. So, yeah, so we're just looking at U right here. One thing I guess I can do real quick before moving into Flow is demonstrate the Python engine. So I'll click on the Tools menu, click on Python variables. Now I get this menu up here, and this will allow me, I'm going to calculate wind speed. So I'm going to click on New, and my new Python script is going to be called wind. And then, let's see, move this out of the way. My input variables are going to be U, V, and W. So I'll go to my 3D tab, click on U, V, and W, click on New, call my variable wind, and then the output grid, I think we could do a better job showing our output grid. But what this is saying is on X, Y, and Z, is this worth even explaining? There are 3 dimensions in this data set, and they're defined by the variables XH, YH, and ZH, and we're delineating those. We're saying that the grid is XH by YH by ZH, and so we're using the character X to designate which dimension is what, and so that's really confusing. XH by YH by ZH. So anyways, create a new wind variable, and basically from here you can write a Python script that defines new variables. I guess that's kind of obvious. But one of the things that I wanted to talk about is Vapor comes with some utilities. Let's see. There's a file that you'll get when you download Vapor called Vapor Utils, and maybe here it is. So this is a Python script that defines a whole bunch of useful functions. And what I'm going to use is the mag function, which returns the magnitude of 1 or more vectors. I'm going to use my U, V, and W vectors to define a magnitude of wind speed. So I will do from Vapor Utils, which is that script we just looked at, import star, and then I'll say that wind, this variable that I created up here, WIND equals mag U interp V interp W interp. I will test it. Test passed, save it, and then close. And so now what I can do is, instead of looking at uinterp, a volume rendering of that, I can select wind. And you'll notice this takes about 3 times longer to do a rendering that uses 3 variables because we have to load 3 times as much data. So here's our wind speed variable. And let's, again, this is a modal distribution, so I will load a built-in color map, a sequential one, and let's go with black body, because I think that looks cool. And then let's mask out some of our values, so we're only looking at the high wind values of the tornado. Yeah, something like that. Okay. I'm gonna call that good enough. So now we're looking at the high wind region of our tornado. Let's make a flow renderer. This is probably Vapor's flagship renderer. So let's jump into it. I'll click on New, double click on Flow. And so Vapor supports 2 different kinds of flow. We call them path lines and streamlines. And so the first one I'm going to cover is the streamlines because it's just simpler. My variables are defaulting to U, V, and W, these interpolated values for U, V, and W. And I'm going to go to my seeding tab. And this tab is unique amongst the renderers in Vapor because it allows us to define where we're injecting our particles, our seed points. And so you can see the first thing that we have to define is the flow type. Streamlines or path lines. Like I said, I'm going to do streamlines. You can define what direction you're integrating your flow lines, integration steps. I think the best first thing to do is just to turn the thing on. And right now we can see these streamlines going through our domain. And what a streamline is it's just a line that's following the wind vector that we've specified. It's completely time invariant. So at this single time step, if we inject a seed right here in the middle, we can see this seed was injected right in the middle of the domain. If we follow that trajectory of the wind vector, that's the path that it would take. And then from there, we can play with different parameters like the integration, number of integration steps, how many times we're moving this particle through the domain. So if I turn that to 10, everything should shorten. And by increasing it, they get a little bit longer. Some other things I'm not going to get into, like vector field multiplier, periodicity on the grid. I'm going to scroll down and the seed distribution type. This is the way that we are applying seeds into the domain. So right now we're putting 5 seeds along the x-axis, 5 along the y, and then 1 along the z, and right in the middle of the z-axis. So here's the top of the z, here's the bottom down here. And so we're putting 1 slab of seeds on a 5x5 grid right in the middle. When we're in the seeding tab, we also have these control handles, which pertain more to where the seeds are being distributed than the geometry tab. Like if I go to the geometry tab, I can constrain the scene like that. And now we're cutting off all the seeds on this left part of the domain. Whereas with the seeding tab, if I go here, I can constrain where the seeds are being put. It kind of like lets you specify where they're going. So if I right click on this handle and drag them all the way down to the surface, now our 5x5 grid of seeds is right here, squeezed here at the bottom. I'm going to increase my integration steps back to 100. And now we can see these streamlines being advected up into the tornado. I'm going to constrain my seeds further by bringing them closer into the vortex. And now my 5x5x5 grid of seeds is right here down at the bottom of the funnel. You can see how they're getting advected that way. Let's see, I've got 8 minutes left. One thing I want to mention for one of the best features of the flow renderer is the ability to sample data along these streamlines. And so if we wanted to write a text file that specified the wind values along each one of these lines, we can do that at the very bottom by clicking on wind and then writing it out to a text file. And then in my home directory, I'll have a vaporflow.txt file that will tell me what the wind speed is along the streamlines. And we've had a lot of requests for that from scientists. And so that's a kind of a new feature that we offer. I'm going to create another flow renderer and see if I can get through some path lines before talking about some data stuff. So I'll click on flow, create a new flow renderer, turn off my old one, and I'll go to my new one, and I'll click on path lines instead of streamlines. And the difference between a path line and a streamline is that a path line is time variant. The path line, the particles that we inject into the scene with path lines will change over time. So streamlines will change over time, but they're not following the vector field in between time steps. So if I turn on my pathline flow renderer, let's see, am I missing something? Injection interval 0, I should see something here. My geometry is full, my seeding is pathlines. Let's see if maybe I can crank up the number of seeds I'm injecting. I'll go to 12, maybe 10. Huh. Variables tab. I'm looking at U, V, and W. Maybe there is a bug, or maybe I'm missing something fundamental. Change my injection interval to 1. Still nothing. Vector field multiplier. Let's see. I'll multiply my vector field. Maybe they'll get bigger if I do that. No. Huh. Well, this is something I'll probably have to investigate offline, and the flow renderer really does deserve its own tutorial in itself. And so, yeah, I'm not too sure why this is not working. Enable, re-enable, no. Well, the Streamlines are working. I hope that one at least is clear how that works. Yeah, this is a mystery to me. Gosh. So did I only import one time? Let me test. Should probably turn my renderers off for this, but I thought I imported 5. Yeah, okay, interesting. So at the first time step, okay, I got it. So yeah, that was a good point. At time step 0, the streamlines they haven't advected anywhere yet. And so, or the path lines haven't advected yet. So I'll turn off my streamlines, and now we're looking at path lines. Let me see if I can make this look more reasonable now. Turn my vector field multiplier back to 1. And they're still quite long. Turn down the path line length. Oh, yeah, that's interesting. Let me, for demonstration purposes, let's just do a 3 by 3 grid. Those are still quite long. Let's do this, see if we can reduce the vector field. And then I'm just going to animate this through time, turn off the volume renderer for rendering time's sake. But we should see the seeds now advecting as we press this play button and march through all the time steps. Yeah, they're still pretty long, but yeah, I guess I blew the demo for the path lines. But again, I think this really deserves more time and more dedicated tutorial for this. So if you guys are familiar with our YouTube channel, we'll probably put a tutorial for that if you subscribe there, probably in the next couple of weeks. So yeah, time step 4. Yeah, I can probably do a lot better job on that one. But I'm going to talk real quick about the CF conventions and getting your data into Vapor. So again, what we're doing to get data into Vapor is we're clicking on the File menu and importing it. And then we can natively read WRF ARW or NetCDF CF compliant data. NetCDF CF compliant data is basically, it requires a certain set of attributes on each variable. And let's see. I thought I had a tab open on this. Well, I think, yeah, let's see. I think I have it in my presentation. So, okay, let me open this up. So on the left over here, we have a simple NetCDF file with an X, Y, and Z dimension defined as well as time. And then we have a variable temperature defined according to time, Z, Y, and the X axis. In order to get this to be CF compliant, we need what are called coordinate variables. And a coordinate variable just describes where in space a dimension exists. And so in the CF conventions, a coordinate variable is just a variable that's named the same as its dimension. So we have an X coordinate variable here that is according to X. And this just defines where each grid point on the X axis is. So it can be at 0 meters, 50 meters, 100 meters. And same goes for the Y axis or the Y coordinate variable and the Z coordinate variable. Below these variables, we can see what are called NetCDF attributes. And so we've given the axis attribute to X, Y, and Z, and those are defined as capital X, Y, and Z. And that allows Vapor to know that these coordinate variables define these axes in space. The other coordinate variable we have is time, which also has the attribute of T for its axis, and also has a unit so that we know for things like the flow renderer, how fast the wind is going per time step. And then like the simple example over here, temperature is just like it was earlier. It's defined as our temperature along the time coordinate variable, the z, y, and x coordinate variables. So in order to do this, there's a tool called NCO. Let's see. Oh, looks like I'm out of time. There's a tool called NCO. If you check out our documentation, if you go to www.vapor.ucar.edu, go to our documentation, and there's a section called Getting Data into Vapor 3. This will explain the process for getting your data to be CF compliant. So yeah, I'm out of time. I just want to thank everyone again for joining us. And I guess I want to ask if anyone has 5 minutes, there's the link to our survey. If you want to see a new feature in Vapor, this is your chance to kind of steer us on what we do next. So yeah, please fill that out if you have the time. And I think I'm going to read through the chat, and if there's any unanswered questions, I can try to find email addresses. And if that doesn't happen, www.vapor.discord, is it discourse.group? You can feel free to ask questions on our Discord forum. So thanks again, and I will catch everyone later.